Hi all, this is Tim Olson. In this demonstration, we're going to show how the 3D print tools work in conjunction with a large STL file. Let's go ahead and import our STL file through the File, Import, Import Type. We're going to pick STL, and for the units, we'll go millimeters. And let's go ahead and select our file. It's a large pelvis scan, and bring it into the system. Now, STL files do not have a file unit designator, so you have to go ahead and pick the type as you import it. Now that we have our STL file imported, we can see we have quite a few facets and edges. Now, one thing we can do is to help reduce some of the clutter is to turn off all of the edges that are being displayed. This particular model has over 1.5 million facets, where each facet has 3 edges on it, so it gets kind of messy. So what I'm going to do is I'm going to go over to the View, Shade Options, and we have a static display mode and a dynamic display mode, and I'm going to set the static to Phong. I'll also set the dynamic to Phong. Now, dynamic, that's when you go ahead and use the middle mouse to dynamically rotate or dynamically pan. And so we'll set both those display methods the same. And now let's go ahead and view our model. Okay, next let's go ahead and display our 3D print tools. And we'll go to the Power Pack, 3D print tools, and let's look at the first tool, which is a 3D print check. This is what I'll typically run on a part, just to get a general idea of what's right or wrong with it. So let's select our tool and select our model that we want to analyze, and let the tool go ahead and analyze away. This thing tells you whether there's open edges, whether it's closed. It tells you the length and width. It tells you whether you have any collapsed facets, the volume, the alignment, manifold edges. This is telling us this part has non-manifold edges, it's not closed, has some normals issues, appears to have duplicated facets, and it also has over 1 million facets, where we point this out because some services such as Shapeways will not print or accept models over 1 million facets. It also tells us the part is outside of the printing platform volume for the referenced printer, which we have as a MakerBot. So let's go ahead and next look at the normals. And normals are a great way to find out if you have not only whether you have proper orientation of all the facets in your model, but it also lets you know if you have any gaps or holes in your model. And we can see up on top here we do have we have a large opening, and all of the facets that are part of that opening are displayed in red. Now let's look at the model from the bottom, and we see we have several holes as well. Next, let's look at the Overhang Tool. And the Overhang Tool tells us if we have areas that may not be printable without support added into the manufacturing of the part. And we can see that these areas in red are areas of possible concern. The next tool that we're going to look at is thickness. Thickness tells us whether we have a wall thickness that may be too thin to create with a 3D printer. And we'll specify a thickness that we want to have identified. Again, this is a visual tool that identifies thin areas in red and acceptable areas in green. And we'll go ahead and pick our part. Now, this is the minimum thickness goes in and examines every facet's relationship with another facet. And for a model of this size of over 1.6 million facets, this is going to take a long time. So one of the things you'll see for those commands that take a long time, you can look up in the prompt area and see, hey, press escape to abort. And so that's what I'm going to do in this case. I'm just going to hit escape and abort out of this command. And you can do that command if you can sit around for a while. Next, go to slices. Slices will take 2D slices of your given orientation through a part. It helps you understand your part from the way that it will be printed in layers. And let's go ahead and we're going to slice it along the z-axis. And I'm just going to do 20 steps, and I'll hit play. And you can see the various complexities of this shape as it slices upward. Now you can move up with your mouse, move it in and out into various areas. You can also, stop it and continue. You can go forward one at a time. You can jump all the way to the end. Let's zoom up on that end slice. You can see it's pretty wicked up there. You can also save your slices. You can save them off as a DXF file, an STL, or you can add it right into your drawing, where each of your slices get displayed as into a layer. Okay, let's quit out of that command, bring us back to our model, and now let's go ahead and one of the 3D print warnings was that the part was outside the volume for the given printer. So we're going to go ahead and display our printer volume, and then we're going to use a tool to go ahead and position it. Now you can select from a variety of ways to position your part. You can do what we call optimal packing, where if you have a bunch of parts and you want to put them on the table closely packed. Or you can rotate and align a part onto the bed. Or what we're going to do is we're going to do centered. And all this does is it takes your part and centers it into the volume area. Now you can see we're actually larger than our volume, so I'm going to use a tool under the Utilities section that lets me scale things very quickly. And what I'm going to do is I'm going to scale this. Let's just scale like down to 0.85, and you can see down below the scale it tells you what our model extents are after this particular transform. And this looks like this one. I'll fit inside my printer definition. So let's click OK. And let's go back and center it one more time. There we go. And so now we have our part fitting inside of the volume. Some other things that we can do with the part. Let's go over to the Power Pack and the 3D mesh tools. These are all tools that you can use off of a mesh. For example, let's see where all their free edges are. These are edges that are not connected to other facets, meaning it's an open or a gap in the model. And these edges are highlighted in red and displayed as line entities. So let's go ahead and click OK, and let's zoom up, and you can see, hey, here's all the free edges up on top. That's quite a complicated opening there. And then over on the bottom, we can see we have the two large holes. Now, once you're done visualizing, or you have any, no longer have any need of those edges, I'll just go back and undo free edges to get rid of them. The other thing that I find very useful in analyzing a part is to show non-manifold edges. Now, a free edge, that tells you you have a facet that's not connected to anything, producing a gap. Now, a non-manifold edge means that for any given edge, you have more than two facets connected to it. That's usually a sign that there's something wrong and it's not really a properly closed volume. Now, in this case, we have 17 non-manifold edges, and like the free edges, these are shown as red lines over the edge. And let's see if we can turn off the model. You can see these are all the locations that it found. And what I'll do is I'm just going to pick this one area, and I'll turn my mesh back on. And then if we zoom in, oh, this is actually, we're inside of it. There's some holes going into it that are producing some non-manifold edges, and that may make this part difficult to print without some corrections. And that's it for our quick overview of the 3D print tools.